So question 9, a uniform plank has weight 100 and length 4. It rests horizontally in equilibrium on 2 smooth supports, where AC is X and CD is 0.5. See diagram. The magnitude of the reaction of the support at C is 75. Modelling the plank as a rigid rod, find the magnitude of the reaction of the support on the plank at D. Well, actually, the first thing about this is there's only one force acting downwards, and that's the weight of the plank. There's only 2 forces acting upwards. That's the reaction at the 2 points. If you resolve vertically, and the plank is in equilibrium, it's at rest. So if you resolve vertically, you've got the reaction at D plus the 75 that we're told is the reaction at C is equal to 100. So it is 25 newtons, that's it. And it was only 1 mark. Now, part 2. Find the value of X. So we are going to have to take moments about something in order to solve this. X is the distance from A. So it kind of makes sense to take moments about A, doesn't it? You might have drawn a diagram. Should we have a quick diagram? There's the plank. This is the point A. Here is the point C. And here is the point D. We've already got that the reaction at C is 75. The reaction at D we now know is 25. It's a uniform plank, so its weight acts in the middle. So that is the 100 that's acting in the middle. Have I got everything right on there? Its length is 4 meters. So that distance there is X. What else have we got? We've got that distance there is 0.5. And we've got this distance here is 2. If I take moments about A, then the only force of the clockwise moment is 100 times 2. The anti-clockwise moments are 75 times X and 25 times X plus 0.5. And that's my moments equation. If I collect things together, then I've got 200 is 75x plus 25x plus 12.5. So 100x is equal to 187.5. So x is 1.875 meters. There we go. It's not that bad, is it, when you look at it like that? Then a stone block is now placed at the end of the plank at B, and it's on the point of lifting. So actually I'm going to add this in as an extra little bit here. We've got a stone block placed at the end of the plank at B, and it's on the point of tilting. So that would now have a weight, which I'm going to call W. Some of the other things have changed. I actually feel like I ought to have done a new diagram. Is it alright if I sketch out a new diagram? Because I want to change the other things that have gone on there. So what have we got? We've got, there's our plank again. There's still A. Oh, hang on. There's A. Now the point of tilting about D. If it's on the point of tilting about D, that means that this force here at C is now 0. It means all of the reaction is at that point there, at the point D. We still have the mass of the rod, the weight of the rod as being 100. We now have this additional weight here that's at the end of it. And we're going to take moments now and try and work out what's going on with this. We know some of the things, don't we? So we know that x is 1.75. So actually, that distance there is, we could work out that distance, couldn't we? Would that be a sensible thing to do? So that distance there, if it's 1.875 to that point, and then another half to there, so we're going to do, that is 4 take away 1.875 plus a half. And so that gives me 4 take away 1.875 take away the other half. So that is 1.625. Now I could take moments about either side. It doesn't matter which point to take moments about. I'm going to take moments about where would be a helpful place. I'm going to take moments about the point D, because that eliminates the reaction. The other thing I could do is I could resolve vertically and work out that that the reaction is 100 plus W, and then just take that into account. But I'm going to take moments about D. If I can get the pen to work. Eventually. Come on. Maybe I'm not. Maybe I'm going to do it then. Take moments about D. Why won't it let me go onto a new page? And I have W. It's not going to let me write on this new page, is it? And this is all gone wrong now. Right, we'll we are going to just take a pause in the video. We'll just play some music in the background. Somebody, Dan, do some music in the background while I close this and open it again.
It's just fantasy. Caught in a landslide, no escape from reality.
This is great. I'm now going to have a copyright claim, aren't I? From that's the last thing. Well, I think.
I'm just a poor boy. I need no sympathy because I'm easy come, easy go.
Right, I think he's still going. Oh no.
Are you recording?
Yeah, I'm recording still. Unbelievable. Right. If this works, we're going to carry on. Yes, it works. Right, we're going to take moments about D. Thank you. That was really, really lovely. I think the one thing that will work in my favour is there won't be a copyright dispute, because nobody could possibly have recognised that as being any song that ever existed ever. So we got away with it. Right. So we've got W times 1.625 must be equal to, and that must be 100. Oh, we need this distance as well. Well, if that's 1.625, that distance is 2 minus 1.625. So that remaining distance is 0.375. So the weight is equal to that times 100 divided by 1.625. And that gives me 23.1 newtons. three significant figures. There are a number of ways of doing that, because you could have taken moments about any point and done that in a combination of resolving in different directions. There's no way that is particularly neat for doing that. That's probably the neatest, but it's still a bit fiddly, isn't it? Then it said, explain the limitation of the modelling. Part 4, modelling the stone block as a particle. What's the problem with doing that? Well, the particular thing about that is you're assuming you are taking the weight of the block to act at the very, very end of the plank. And if you have a stone block balanced on the end of the plank and all the weight is at the very tip of the plank, how is it balanced? That's pretty precarious, isn't it? So one of the things there is you're modelling it as being exactly at B, and you're ignoring the dimensions of the block that there would need to be there in order to take it. So we've modelled it. We modelled the block's weight as acting at the very end. Exactly at the point. It was B, the end of that, wasn't it? Exactly at B. So we've ignored its dimensions. Another thing that would have got the marks there is commenting on the fact that we've modelled it as being a uniform block, and that's, it was just a stone block. How many stone blocks are perfectly uniform? The last bit, so part B in this one, the plank is a rigid rod. Well, that has assumed that it does not bend, and that's the limitation of the modelling. We've assumed the rod doesn't bend. And actually what we've done is we have put a heavy block on the end of a rod that's balanced on some pivots, and so that's an assumption. The rod would have bent rather than just tilted. There you go. And that was a very long video.